All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to do remove, replace, reduce. So we're going to have x squared minus 22x plus 40. Then you're going to factor that. X minus 20, x minus 2. You're going to replace the 5 in front of your x's. The first one will divide by 5, so you'll have x minus 4 times 5x minus 2. And so that is your answer for that one. For the math knowledge question, we have a vertex of 3, 7 and an axis of symmetry at x equals 3. It crosses the x-axis at 3 plus the square root of 21. Where else, if any, will it cross the x-axis? So I'm going to graph this a little bit. So we have 3, 7. There's your vertex. And it says it crosses it at 3 plus the square root of 21. So we're going to go over the square root of 21. So we'll say this number is 3 plus the square root of 21. And then it's going to come over here somewhere. And it's going to be over the square root of 21. Well, this is 3, and we're going backwards by square root of 21. So you're going to do 3 minus the square root of 21. So that's A. So that would be the answer for your math knowledge question. The only time it would be no point is if the vertex were on the axis of symmetry. Otherwise, you're always going to cross the x-axis at 2 places or at no places. So if it crosses at 1, it's going to have another unless it was the vertex. Okay, so we're looking at lesson 27. We're going to do equation of the tangent line, and then we're going to look at higher order derivatives. So hopefully after the lesson you'll be able to do equations of the tangent lines, and then you'll be able to do higher order derivatives. So the slope of a line that is tangent to a curve at some value of x can be found by evaluating the derivative at that value of x. So we've gone over that a little bit. If we have a curve and we want to know what the slope is at this point here, we find the derivative and then we plug in whatever your x value is. Okay, so we want to find the slope, the derivative, at 3. That's what that says. Compute the derivative at a value of 3. So the first thing we need to do is find our derivative. So the derivative of x squared would be 2x. Derivative of this next term would be minus 4. And derivative of 3 is 0. So then you take your derivative and you plug in 3. So 2 times 3 minus 4. 2 times 3 is 6. Minus 4 is 2. So that's your answer. So that's how it could ask you to compute the slope, compute the derivative at a specific x value. Sometimes it'll ask you for the equation, like this one. So we want to find the equation of the tangent line, not just what the slope is. So this is the same equation that we just had at x equals 3. So we know that our slope, our derivative, equals 2, because this was the derivative. So that's the slope that we're going to use. So we're going to have y equals mx plus b. We know that our slope is 2. We do not know our b value. So we're going to need to figure out our x value. They told us it was 3. And our y value. So the way you find your y value is just to plug in to this equation. So if you plug it in, you get 9 minus 12 plus 3. So your y value equals 0. So 0 equals 6 plus b. So b is going to be negative 6. So your equation for your tangent line is going to be y equals 2x minus 6. So if we have our graph, this is a parabola, and we'll say that x equals 3 is right here. I don't know what it looks like. We'll just graph it like that. So we know that the slope was 2 from the previous problem, and we now know that the equation of this line looks like that. That would be your actual line. So that's what you just found. Okay, so let's look at another one. We want to find the equation of the line tangent to the graph of y equals x when x is pi over 6. So first off, we need to find our derivative, which is your slope. So the derivative of sine, anybody remember what it is? Derivative of sine is cosine. Okay, so that's your derivative, and then we want to evaluate it at pi over 6. So what is the cosine of pi over 6? That's the same thing as 30 degrees. So what is the derivative of, what is cosine of 30 degrees? Square root of 3 over 2. So our derivative, our slope, is square root of 3 over 2. So now we have to find our equation. So y equals mx plus b. We know that our m is square root of 3 over 2. We know that our x value is pi over 6 because they gave it to us. We don't know our y-intercept. And then how can we find our y value? Well, we're going to plug it back into this equation. Y equals the sine of pi over 6. So what is the sine of pi over 6? 1/2. So your y value is 1/2. So you can combine that into one term if you want, or you can leave it like that. Your b is going to be 1/2 minus, if you make it one term, you'll have square root of 3 pi over 12. Okay, so your equation would be y equals, our slope was square root of 3 over 2 x, and then plus 1/2 minus square root of 3 pi over 12. So that would be your answer. All right, we're going to look at another one. Find the equation of the tangent line to sine of x when x equals 1. So first we need to find our derivative, which is our slope. So what is the derivative of sine? Derivative of sine is cosine, and we want to know when x equals 1. So what is the cosine of 1? That's radians. Do you know the cosine of 1 off the top of your head? Probably not. So we're going to use our calculator. Make sure that it is in radians. So the cosine of 1 is 0.5403. Okay, so that's the cosine of 1. So that is your slope. So now we're going to use y equals mx plus b. Our m we just found was 0.5403. Our x value is 1. We don't know our b. That's what we're looking for. How do we find our y value? Well, y equals the sine of 1. So again, you're going to use your calculator. The sine of 1 is 0.8415. So 0.8415. Okay, so if you solve for b, should get 0.3012. And so your equation would be y equals 0.5403x plus 0.3012. So that would be the equation for your tangent line when x equals 1. Again, we had to use our calculator in radians because we don't know what the cosine of 1 or the sine of 1 is. Okay, so now we're going to look at higher order derivatives. If your function is f of x or y, then the first derivative we've dealt with, f prime of x or dy over dx. But you can take the derivative of a derivative, which is the second derivative. And so you would write f double prime or d2y, or it says d squared y over dx squared. So that's your second derivative. And then your third derivative you can write as f triple prime or d cubed y over dxy cubed. So again, you have two different notations because two different men created calculus. So depending on who created it, as to which one of the formulas they created. We're going to use both of them interchangeably, so you need to be familiar with both. So on this one, we have a function, and this should actually be a u here. There should be a u there because our variable is the u. I made a typo. Alright, so we have a function, and we need to find the second derivative. I know it's a second derivative because there's a 2 here and here. They're never going to give you a 2 and a 3. They're always going to be the same number. So the first derivative, we would do 3 and then 5u to the 4th, because 5 minus 1 is 4, which is 15u to the 4th. Then the second derivative, you would do 15 4u to the 3rd. So you would have 60 u to the 3rd. And then it says evaluate it at 2. So if you plug in a 2, you have 60 times 8, which is 480. And so that would be your answer for that one. Okay, so now let's look at this one. We want to find the third derivative because we have f double prime. So first off, we need to put it so that it's in the numerator. So 1 over x is the same thing as x to the negative 1. So if you think you can take the second and third derivative of this one, go ahead and try that. Alright, so the first derivative, you're going to do negative 1 x, negative 1 minus 1 is going to become negative 2. For the second derivative, you're going to do negative 1 and then negative 2 x to the negative 3, which is 2x to the negative 3. Okay? For the third derivative, we're going to take 2, and then we're going to do negative 3 x to the negative 4, and so we're going to have negative 6 x to the negative 4. Okay, so we've got the third derivative, and we need to plug in a 2. So f triple prime of 2 is going to be negative 6 and then 2 to the negative 4. So if you put the 2 to the positive 4 in the denominator, 2 to the 4th is 16. And so 6 over 16 is 3 over 8. And so that would be your answer for that one. Okay, so that's how you deal with higher order derivatives. your homework tonight, you do get to omit number 12, but make sure that you do the other ones so that we can go over any questions that you have tomorrow.